So here the reaction of bases with non-metal. So what are these bases? How they are going to the oxides of non-metals when react with the bases? What are the products are going to form? So here when bases react with oxides of non-metal to form salt and water. So here these oxides of non-metals when bases react with oxides of non-metals, they produce non-metals to form a salt and water. When bases react with the oxides of non-metals, they form salt and water. Okay. So here, even though when metal oxides react with dilute acid, they also produce salt and water. And here also, when bases react with the oxides of non-metals, they are also going to form salt and water. So here, the oxides of non-metals are usually said to be acidic in nature, and sometimes it is considered as the oxides of non-metals are acid. Okay. So here the reaction of bases with oxides of non-metals, usually the oxides of non-metals are acidic in nature. Usually the oxides of non-metals are acidic in nature, and sometimes these oxides of non-metals themselves are said to be examples of acid. So here we know that when acid with base, the salt and water is going to form the same relation here. Okay, these are what when the bases react with the oxides of non-metal. Let us consider here examples. Told you when bases react with the oxides of non-metals, they are going to form salt and water. Write on the general equation. Okay, how you are going to write that general formula? Bases plus oxides of non-metal. Oxides of non-metal. What are the products here? Salt plus water. Okay, salt plus water. Bases plus oxides of non-metal, salt plus water. So here let us consider the example. This is a general formula. Okay, examples here. Let us consider carbon dioxide. Okay, when carbon dioxide react with the sodium hydroxide. When carbon dioxide reacts with the sodium hydroxide. So what is the state of carbon dioxide here? Gaseous state. And sodium hydroxide? Aqueous. Okay, what are the products are going to form here? Sodium carbonate, Na2CO3, sodium carbonate. Okay, plus water, H2O. What is the state of sodium carbonate? It is also aqueous. Okay, so here it is aqueous solution and water liquid solution. Okay, so here when the bases react with oxides of non-metal, these are the oxides of non-metal, carbon dioxide. Okay, base is what? Sodium hydroxide. When carbon dioxide reacts with sodium hydroxide, it is going to form its salt, that is sodium carbonate. Okay, it is on sodium carbonate and water. Then take on another example. Another example here. Take carbon dioxide and base as potassium hydroxide. What is the base here? Potassium hydroxide. Then what is this salt is going to form? form here? The salt is going to form potassium carbonate, K2CO3, potassium carbonate plus water. Okay, so here when bases and oxides of non-metals, they are going to form salt and water. Okay, take on another example here. And usually whatever the oxides of non-metals are there, they are acidic in nature. Remember that. Okay. Then next one, take on sulfur trioxide, SO2. Okay, sulfur trioxide, SO3 we consider, plus when this sulfur trioxide react with the sodium hydroxide. Sodium hydroxide, what are the product it is going to form? It's going to form its sulfates, Na2SO4. Sodium sulfate, Na2SO4 plus water. Right? Sodium sulfate. So whenever the oxides of non-metals react with bases, they are going to form salt and water. Example here, consider carbon dioxide react with sodium hydroxide, it forms sodium carbonate and water. Again, when carbon dioxide react with potassium hydroxide, KOH, potassium hydroxide, it is going to form potassium carbonate and water. Then sulfur trioxide reacts with the sodium hydroxide to form sodium sulfate and water. Right? Okay. Then next is some metals are there, or metal oxides, when they react with bases. Okay, when they react with acids or bases, some metal oxide, few metal oxides are there, when they react with the acid or base, in both the cases they are going to form salt and water. So such type of non-metals are known as, such type of oxides of metal are known as amphoteric metal. Okay, such are known as amphoteric oxides. Okay, some oxides which are some metal oxides, they react both acids as well as base to form salt and water. Okay, to produce salt and water. Such metal oxides are known as amphoteric oxides. Okay, so here now we will discuss the amphoteric oxides. Okay. The metal oxides reacts with both acids as well as bases to produce salt and water. Okay, some metal oxides such as what are those metal oxides? Okay, so here those metal oxides are zinc oxide and aluminium oxide. Zinc oxide and aluminium oxide. Zinc oxide and aluminium oxide. Some metal oxides such as zinc oxide and aluminium oxide react with both acid and bases. React with both acid and bases to produce salt and water. Produce salt and water. These oxides are called these oxides are called amphoteric. Make it in a capital here. Amphoteric oxides. Okay, that's why I use that letter. Amphoteric oxide. So you have studied this one in 8th class, right? Amphoteric oxides. So during while studying metals and non-metals, study that amphoteric oxides. There, so these are the metal oxides. When these metal oxides react with acid, then also they are going to produce salt and water. The respective salt, like zinc salt and aluminum salt, and also they will produce water. And even when they react with base also, they are going to produce salt and water. So this such type of oxides of metal are known as amphoteric oxides. Some metals, especially here it is zinc oxide and aluminum oxide. Let us see how they are going to react. Okay, that is zinc oxide and aluminum oxide. So zinc oxide plus sodium hydroxide, ZnO plus NaOH. So what is the salt is going to form here? Na2ZnO2. So Na2ZnO2. Okay. Sodium zinc 8. Okay. How we are going to write this one? Sodium zinc 8. Okay. Then plus water. That is sodium zinc 8. Okay. So here some metal of oxide, special zinc oxide. What is the state of zinc oxide here? The state of zinc oxide is solid and state of NaOH is aqueous. And what about the salt? It is also in the form of aqueous. Okay, the state is aqueous. Then next, aluminium oxide. When aluminium oxide react with sodium hydroxide, Al2O3. What is this? Aluminium oxide, Al2O3. Okay. When this aluminium oxide react with the sodium hydroxide, what is going to form here? Sodium aluminate, 2NaAlO2. 2NaAlO2. What is this? It is a sodium aluminate. Okay, write down here. Sodium aluminate plus water. Okay, so here the metal oxides, especially zinc oxide and aluminum oxide, when they react with acids as well as bases, they are going to form their salt and water. So already in previous class we studied that these reactions, zinc and with respect to acid, zinc oxide with respect to acid, and aluminum oxide with respect to acid. Okay. So I have given you that is Zn plus H2SO4. Okay, where it is going to form zinc sulfate, ZnSO4. Okay. Zinc oxide plus H2SO4. Zinc oxide plus H2SO4. How we are going to write here? Zinc sulfate, ZnSO4. ZnSO4 plus water H2O. Okay. So like this you can write. Now you can take here also. Write down for aluminium. Okay. Al2SO4 aluminium oxide plus bases, they are going to form their salt. Okay, in the previous class we discussed Al2O3 plus hydrofluoric acid. Okay, when it reacts with the hydrofluoric acid, it is going to form aluminum fluoride and water. So next we move to that. What do all acids have in common? So now we studied all the chemical reaction, all chemical properties we studied, right? Among these all chemical properties, what we come to know that, what is the conclusion, means what all the properties resembles. Almost all acids have the chemical properties, the same chemical properties, right? The acids which shows the same chemical property. What is that same chemical properties? Okay. Then what is the common in that acids? What do acids have common? What is that common? So here, when these acids dissolve in water, they are going to produce that H plus ion. What is that? H plus ion. So here, the ions electrolysis. Okay, they conduct electricity. So due to that, because of that reason, why they conduct electricity? The reason behind that is when they are going to dissolve in water, they are going to produce that H plus ion. So because of that, they conduct electricity. So here, now the heading is, what do all acids have in common? What do all acids have, what do all acids have in common? Okay, so what is that in common? Let us discuss. Acids possesses a number of common characteristic properties. What are those number of common characteristics? Let's see that H plus ion is going to produce when they dissolve in the water. So here, all acids produce hydrogen gas. All acids produce hydrogen gas. All acids produce hydrogen gas on reacting with metals. On reacting with metals, right? All acids produce hydrogen gas on reacting with metals, and hydrogen is common to all acids. That's why on the basis of number of hydrogen also, the acids are classification, the types of acids depending on the number of hydrogen ions. Okay, so that is what basicity we have calculated. So here, these all acids produces H2 gas on reacting with metals, and here the another one more characteristic of this acid is they conduct electricity. What is that? Conduct electricity. Okay, so you can say that, ma'am, bases also conduct electricity, right? That is in when all the bases, what all the bases have in common, then we will discuss that. What is the common characteristic of bases? And here the common characteristic of acids are, all acids produces H2 gas on reacting with metals, and they conduct electricity. So the reason behind why they conduct electricity here. So they conduct electricity when acidic solution. So here, when they dissolve in water. Okay, the special characteristic is what? They conduct electricity. The another is that the aqueous solution of an acid conduct electricity due to the presence of charged particle called H plus ion. So almost all in aqueous solution, I told you, when their acids are conduct electricity, the characteristic solution, the solution must be aqueous solution. Okay, in aqueous solution, acids conduct electricity. Acids conduct electricity. They conduct electricity. So due to the presence of charged particles called H plus ion. Charged particles called H plus ions. So here the common characteristic of all the acids is, and they dissociate of, so almost all these acids, they are going to dissociate to produce H plus. I told you, if they dissociate in any of the aqueous solution, water or any of the aqueous solution, they dissociate H plus ions. Due to that dissociation of H plus ions, they conduct electricity. Okay, they conduct electricity. These are the common characteristics are present in a acid. Then how it is going to form? How this dissociation of acids are going to produce that H plus. So here let us consider HCl. It is an acid which is in aqueous solution. When it dissociates, what it is going to form? It is going to form H plus plus Cl minus. So one positive ion H plus and Cl minus. Okay. If we take another acid like HNO3, nitric acid, okay, when this dissociates, it also forms H plus and NO3 minus. So here, when these acids dissociates to form H plus ions, almost all acids, when they dissociate, they are going to produce that H plus ion. Okay, and here one more character is that if there is a presence of H, okay, you can say that in ethyl alcohol and glucose. What is that ethyl alcohol? How we are going to write that ethyl alcohol? CH3. Ethyl alcohol is, C2H5OH. Ethyl alcohol is what? C2H5OH, and here another glucose is what? C6H12O6. You might have said, yes ma'am, in these two compound also hydrogen is there, right? Then why can't we say these two as acids, right? Because here the properties we are telling that if the presence of H plus ion, when they dissociate in water, when they dissolve in water, they dissociate H plus and respective negative ion. But why don't we this ethyl alcohol or glucose are having the H plus? Hydrogen is present. Then why these two are not acids? Because when these are dissolved in water, they are not going to form that H plus ion. There is no dissociation of H plus ion. That's why this such type of reactions, what we used to say that this such type of reactions is to call the common characters where the acids have all the characters. The first, almost all acids produce H2 gas on reacting with the metals, and they conduct electricity, and in aqueous solution acids conduct electricity due to the presence of charged particle called H plus ion. So here when these acids dissociates, they are going to form H plus and respective negative ion, cation and anion. So these are what the common behavior, the common characters of acids. Okay. The next we'll move to that. What do bases have common? Okay, what do bases have common? Okay, this here we studied that when this HCl is dissociated, it is going to form its H plus and Cl minus. Okay, if this HCl in presence of water, if it dissolves, then what happens? It starts moving. Okay, so when this HCl dissolving water, okay, then how we are going to write that? They are going to form their hydronium ions. There exist hydronium ions. So here HCl plus H2O is going to form H3O plus Cl minus. H3O plus Cl minus. So here, what is this H3O? It is a hydronium ion. What is this? It is hydronium ion. Hydronium ion. So when this hydronium ion react with again H2O, there is a presence of H plus. So here, that as each H plus ion can combine with the water, each H plus ion combine with water to form the hydronium ions. Okay, here hydronium ion, how we are going to write that? So how it is getting? Each H plus going to react with the water, H plus and H2O is going to form H3O, hydronium ion. Okay, so here this represents the acids we have in common. These all the acids have the common properties. What are those common? One is when they react with the metals, hydrogen gas is going to liberate and they conduct electricity. The reason behind that is when they dissolve in any aqueous solution, they are going to produce an H plus ion, and that H plus ions, each H plus, when they react with water, they are going to form the hydronium ions. So these hydronium ions, what they do? That's the reason they conduct electricity. Okay. So here one video was there, but it is not playing. Then another reactions, some more example we'll consider here. So you might have seen that H plus will not be existing alone. Okay, it is combined with the hydronium ion. You can't get H plus ion as a single. Okay, it is where it is in presence of this hydronium ion. Okay, then only when it dissolves in water, they dissociate H plus ion. Simply, if any of the acid is going to dissolve in water and H plus will be present, exist? No, it is not exist alone. It is present in hydronium ion. So when this hydronium ion react with water, then H plus ions are going to, okay, then they conduct electricity. Here at this point we'll conclude today's session, then we'll continue tomorrow.